Imagine you walk into a room with a group of strangers. How many people need to be present before it's more likely than not that two of them share the same birthday? Most people guess a number much higher than the real answer. This surprising result is known as the birthday paradox. At first glance, with 365 days in a year, it seems like you'd need a huge group for a birthday match to be likely. But as we'll see, the probability grows much faster than our intuitions suggest. Let's dive into the math behind this fascinating probability puzzle and see why our expectations are so often wrong. Solve the birthday paradox. It's actually easier to calculate the chance that no two people in the group share a birthday, and then subtract that from 1. Where in people, the probability that all birthdays are unique is the product of decreasing fractions. 365 for the first person, 365 for the second, and so on until 365n plus 1/365 for the nth person. This gives us the formula. P no match equals 365 times 364 times 365n plus 1 divided by 365 to the power of n. The probability that at least two people share a birthday is then 1 minus this value. As n increases, the probability of a shared birthday rises rapidly, even with a seemingly large number of days in the year. Let's look at some actual numbers. With just 10 people, there's already an 11.7% chance that two share a birthday. At 20 people, it jumps to over 41%. The famous result is that with only 23 people, the probability exceeds 50%. By 30 people, it's over 70%, and with 57 people, it's above 99%. For larger groups, a Poisson-style approximation can be used, giving a quick estimate. P no match approximately exp n1/2 times 365. Setting this equal to 0.5 gives about 23 people for a 50% chance. This rapid growth is due to the number of possible pairs, which increases much faster than the group size. Birthday paradox is a classic example of how our intuition can be misled by probability. Even though there are 365 possible birthdays, the number of unique pairs in a group grows as n1/2. This means that with each new person added, the number of possible comparisons increases dramatically. That's why collisions, two people sharing a birthday, become likely much sooner than we expect. This principle is not just a mathematical curiosity. It has real-world applications in cryptography and computer science, where similar probability calculations are used to estimate the likelihood of hash collisions and other events.